Friends, on behalf of My Retired Life Foundation and associate institutions, we extend a very hearty welcome to all of you for this interesting and fabulous and also relevant session for all of us. And that's the world of astronomy. To many of us, the world astronomy and the universe related thereto seems to be an extremely mysterious, complex, and intricate issue. But it may not be so. It all depends upon the. It also depends upon the depth you want to go. It all depends upon the area and the perspective you're looking from. And to give a basic idea about this, it has been a long desire of ours to have a session on this particular topic, so that the people who are really interested, they can further go into the sky gazing and the sky watching, etc., etc. They can buy their own telescope and they can proceed further. So we have with us a very eminent personality, Dr. A P Bhat. Dr. A P Bhat will be with us for the next an hour or so to give an introduction to this world of astronomy. And at this stage, I must express my gratitude to Padmakini Madam that she has been instrumental in getting Dr. A P Bhat amongst us. So welcome, sir. And we look forward to an interesting session. Before we start, may I request Padmakini Madam to kindly formally introduce him.
Thank you, Dr. Sengupta, sir. Good evening, everyone. I am Padmakini, member of MRLF, Vice President of Puna Pradnya Old Students Association, Udupi. Today we have among us Professor Dr. S. Ananta Padmanabh Bhat, Udupi, Honorary Secretary of AMEC Admar Mutt Education Council, Bangalore, a great astronomer, life member of Astronomical Society of India, served as HOD of the Physics Department for 20 years and later became the principal of Pune Pradnya College, Udupi. Published many research papers in international journals. During his tenure at Pune Pradnya College, Udupi, he served as coordinator of Aryabhata Astronomy Group, later renamed as Pune Pradnya Amateur Astronomers Club. PAC organized 3-day international conference on astronomy and astrophysics under the leadership of Dr. A P Bhat in 2011. As the coordinator of PAC, organized more than 500 skywatch and stargazing programs across the country. Raised awareness in over 1,000 schools across Karnataka and Kerala about annual solar eclipse of 2019. Released videos as guides to night sky on YouTube. He has won many awards to his credit: Rotary Outstanding Achievement Award, Best Teacher Award, Lifetime Achievement Award, and Ramotsava Prashasti by Pejawar Mutt, Udupi. Great personality, great visionary, very humble. I feel I'm really honored to have introduced you, sir, today. Our members are eagerly waiting to listen to you, sir. Over to you. Thank you so much.
Thank you, madam. Thank you very much. Okay. Once again, thanks to all my senior brothers and sisters. I'm A P Bhat, as a lecturer in Pune Pradnya College for nearly more than 35 years. Enjoyed physics and research in physics, but my hobby is skywatch. Seeing the sky, seeing stars, planets, comets, moon, galaxies, and so on. Enjoying with my colleagues, my students, and public. Today, Madam requested me to speak about introduction to astronomy. Dear senior friends, I planned like this. I will try to introduce astronomy in my own way with slides. Shall I proceed?
Please proceed, sir.
Okay. So I have a number of slides here. I will move in a quick way. Um,
45 minutes and then some question answer.
Yes, sir. No problem. No problem. Whenever you feel I must stop, you can inform me. No problem. Go to direct first play. And yes, just an introduction to the world of astronomy, in which I hope you can see a slide here. Behind this writing, we have Andromeda Galaxy. Indians call this galaxy as Draupadi Galaxy. I'm very happy to say about this galaxy only because it is at a distance of nearly 25 lakhs light years. 25 lakhs light years is that a distance in which to make a distance of this one to sun or to earth, light, which is moving with a speed of nearly 3 lakh kilometers per second, is in need of 25 lakhs years. But with the naked eye, I can see this particular galaxy. That's the beauty. The sky, in the sky, what we can show this galaxy in the month of December, January, February, and so on. That is called Andromeda Galaxy. Friends, I'll proceed now with the different topics. Next slide. Okay. Sir, as I mentioned, my research field is purely physics, in which laser optics. But my hobby is actually astronomy. I enjoyed astronomy too much. Therefore, I'm an amateur astronomer. When we try to see the sky, we can see a white patch from Mithuna Rashi to up to Dhanu Rashi. In the sky, we call it as Akasha Gange, Shira Patha, Milky Way. We are in this Milky Way, in this galaxy. Therefore, we can't see the full galaxy like our Andromeda Galaxy. But whenever we try to see the sky, it is not only Milky Way, it is planets, stars, cluster of stars, and galaxies, and so on. I introduced the different topics that I planned today. They are like this. Totally, my aim is just to talk about stars, planets, moon, particularly super moon and micro moon, because we have next full moon is a micro moon, and constellations, cluster stars, and comets, and so on. Second one is solar system, stars, galaxies, about universe, origin of stars and universe. Particularly, I try to touch upon Big Bang theory, and mainly my aim is we have our students. They are actually our PAC members, Purna Prajna Amateur Astronomers Club members, and they are doing some fantastic work, Skywatch in and around in different schools and so on. And at last, my interesting topic is beauty of nature, particularly the beauty of Earth. These are the topic. Sure, I will finish within 30 or 35 minutes about all these aspects. Next slide. Yes, our sun, our solar system. As we know, we have Mercury, which is at a distance of nearly 6 crores, and Venus is 11 crores, Earth, which is at a distance of 15 crores. This distance is called as 1 AU, 1 astronomical units by we call. Then we have Mars at 24 crores, Jupiter nearly at 74 crores, Saturn maybe up from nearly 145 crores, and so on. So nearly 8 planets, and so much of dwarf planets, and lakhs and crores of comets, and an asteroid belt in which we have so much of stones which are moving around the sun. The power of sun, particularly in terms of the gravitational attraction, is too much. It's too much. Next slide. And whenever we talk about the size of sun, so our Earth is so small. If you try to fill the sun, if the stomach of sun is empty, we can fill more than 10 lakhs of the marbles of Earth. It's too much, so big. That is our sun. But whenever we try to see sun at the morning and evening, we see that red ball like our moon, only because the distance is actually 15 crores from Earth to sun, and the distance between moon and Earth is only 384,000 kilometers. Next slide. Okay, now we are hearing about the flares of sun too much this year, and this time Last week, we came to know that it's an X flare from sun, X flare. But what is our sun? It's too difficult to understand. The plasma, the mass and energy is ejecting and flying out in its own way up to nearly 50,000 kilometers. And it is like that. But we know that from Galileo onwards, from 1610 onwards, we saw some sunspots, dark spots on the surface of sun through telescopes. And there is a 11-year cycle in which for every 11 years, in 1 year, number of spots, sunspots is too much. That is this year. This year we have in 1 month, we have nearly 200 sunspots. Then in next year, there will be no sunspots at all. And what is the reason for all these sunspots? What is going on in the sun? It's too difficult to understand. But it's only because of the complicated magnetic field of sun for 11 years. For every 11 years, there will be the magnetic field of the sun is it is not like our Earth magnetic field. It's very, very complicated. It's because of a complicated magnetic field we can see sunspots and so on. And next slide. Okay, see like that the whole mass, coronal mass ejection we say. But it's not only energy. But not only mass, the whole mass of charged particles are thrown out, and that can be thrown out the whole universe. And if it is thrown towards Earth, yes, we know that our all telecommunication system will be disturbed if the flare is X flare. As I just mentioned last week, we have an X flare, and sun is in a very peak situation now. Okay, next please. Like that, if you try to see the sun image in the telescope, you can see some dots. Usually they will be pairs. It's called as sunspots and so on. Next, please. Okay. If there is no minimum, there will be no sunspots. If there is maximum, like now, we have maximum sunspots, and we can recognize it. Even we prepared a small instrument. I will show you at last. Each school students can recognize the sunspots in their schools. It's possible. Okay. Directly, we must not see the sun, but through telescopes, from small instruments, you can get the image of sun on the wall of the school, and we can definitely enjoy. We can count the sunspots every day, every year, and so on. Yes, as just I mentioned, the coronal mass ejection will be thrown away from sun now, and sun is so active now. This year, sun is so active. Next, please. Because of this activeness of the sun, then there may be some extraordinary activities on the Earth also. I hope you know we have some earthquakes now. Too much earthquakes on the surface of Earth now. It is because of plate tectonics. On the surface of Earth, a thick plates of nearly 50 kilometers. They are actually floating on the surface of Earth, and these plates are actually moving. But when they are touching each other, I hope you know there will be these earthquakes and so on. There may be link between the sunspots, the sun activity and Earth activity, and that is going on Earth also. Today also I observed that there is a earthquake of nearly 7.4 Richter scale near the southern part of America. Okay, like that. So the next please. And okay, next please. Okay, then what is going on? Can you go back to last? Okay, what we observe is, see, we have Earth at a distance of nearly 15 crore kilometers. When this flare is coming towards Earth, we are lucky. Earth is having its own magnetic field, the magnetic field, which will oppose these energetic charged particles. They are energetic charged particles. When they come towards equator, they will be blocked. I hope you heard about ionosphere and so on. They will be blocked on the surface of Earth. But at poles, there will be no force at all because of this charge and magnetic field. They will be parallel. Therefore, they will enter. When they enter towards the pole, we can see the beauty of nature. That's aurora. I hope you heard about this year. We have so much of aurora. That is Bannada Okuli, Rangarangina Bannada Okuli, we say in the northern and southern hemisphere, we can see that side. Yes, we can see this with respect to the satellite images. Next, please. Satellite. Yes, like that. Next slide. Okay, next slide. That's all right about Aditya. That is, we placed the Aditya there. Okay, next slide. Yes, okay, all these purely with the sunspots. Yes, like that. In the Alaska, now this year they enjoyed too much. Different flares of light. The colored light will dance for 20 minutes in the sky. When you go out, see at sunset and sunrise, we see colors. We see it's actually scattering of light. This is not scattering of light. Can you go back? Can you go back? This is not because of scattering of light. It is because of excitation of the charged particles that is there in the at a height of nearly 70-60 kilometers, and they are ionized, and there will be emission of radiation. Actual radiation is emitted that a particular color like green or yellow or orange will dance in the whole sky for 20 minutes. It's a beauty. We say it as aurora. The whole public of northern and southern hemisphere, they are enjoying now this beauty of this. This is beauty because of the hectic activity of sun is going on now. Okay, next please. So I'll proceed to next topic. That's all right. That's all right. Okay, fine. I'll come back to our solar system now. Earlier I mentioned about the distance sun to earth. I call it as number 1. The meaning is the distance is 15 crore kilometer, 150 million kilometer. We call it as 1 AU, 1 astronomical unit, 1 Khagola Mana, just number 1. With that, I can talk about the distance of the different planets. And see, Saturn is at 10 to the power of 1. I mean, 10 AU. 1 AU is 15 crores. So 10 into 15 crores is 1,500, sorry, yes, 150 crores. That is Saturn. Then the capacity of sun is, the gravitational power of sun is too much. It is not only up to planets. We have 2 clouds here. I hope you heard about comets. Comets are stray particles which are dancing in the Oort cloud. It is at a distance of 10 to the power of 4 astronomical units, 10 to the power of 4 into 15 crores. So that there are some particles which are dancing in their own way by somehow or other. If they are attracted towards sun, then they will come and they will move in its own way. I hope you heard about comets. The periodic comets or non-periodic comets, they will come here. The beauty of nature is that they are coming from the other part of the solar system, in which the temperature is so less, and they have a thick ice cloud. When they come towards the sun, the ice cloud is actually evaporating, and hence we can see a tail in the comets. So the gaseous particles which are not moving along with that original nucleus, the stony nucleus, and hence we can see comet's tail. What's a tail? Nothing but this evaporated particles, and it may be up to 1 lakh kilometers. That's the beauty of comets. But it's actually the particles, the stony particles which are coming from the Oort cloud. Okay, so this is our solar system in a very simple way. As we know, they are moving around. The beauty of our sky is that when you try to see the sky, I like moon too much. Namachandra. Such a beautiful entity in which, see, from Amavasya to Hunimi, from full moon to new moon. So beautiful, in which Padya, Vidige, Chadige, Chavati, such a fantastic way in which he is showing some beauty. Of course, it's because of the reflected light from the sun, but we are lucky that we have a beautiful moon. I proceed, okay. Okay, as we know, the planets that we have, this Pluto is very small, Mercury is small, and Mars is small compared to our Earth. Our Earth and Mars are of nearly, Earth and Venus, they are of equal size. Proceed. Purely with respect to the size. Next slide. Okay, one point I've forgotten to say about Venus. I hope you know Shukra. Shukra is Belli Chukki. We call it as the shining stars, they call Belli Chukki. This we can see Venus. Of course, it is too difficult to see Mercury. It is too difficult. It's a challenge. But we can see Venus. See in the evening sky, maybe up to nearly 2 hours. Evening sky, pala. It is shining in such a beautiful way. Usually, our students will say, "So that's a star." It's not a star. It's a planet. Nearly 6 months, we can see the Venus in the western sky after sunset. In the next 6 months, now, we can see Venus in the eastern sky in the early morning. That's a beauty. We can't see Venus at the top. No, it's not possible. Only at a height of 47 degree, we can see Venus because it's an inner planet. Like Mercury. Mercury can be seen only at a maximum height of 27 degree, and Venus is nearly like that. Only point is, this is an image that they have taken by our students through telescope. We have 8-inch telescope, we have 4-inch telescopes, reflection telescopes are in our pack. They had taken a photo. See, this is the photo of Venus. When you try to see the photo of Venus in different positions, different times, see if it is at a maximum height, the photo is like our Tadige Chandra or Jyoti Chandra. And then we can say it is a planet, it is not a star, because it is purely with respect to reflect light. Of course, the shining is because of thick cloud that we have, carbon dioxide, carbon monoxide on the surface of Venus. Okay, next please. Okay, next. Okay, as I just mentioned, the Venus is like that in different time, nearly up to 19 months. It will move on one position, and nearly 6 months in the western region, in 6 months in the eastern region. That's the beauty of Venus. Venus is giving so much of beauty. Therefore, we call it as Belly Chukki or the shining star. That's all. It's a planet. Next planet. Okay, 1 or 2 points that I must add here. We are lucky, sir. We are lucky only because our Earth is not vertical. Of course, it is going round. Can you go back to my presentation, my slide? I mean, I want to see my face. See, everybody's sun. Earth is not moving like this. It is not moving like this. We are lucky. If it is moving in like that, in a straight way, then see, we can't enjoy all these ritus. Vasantarasu, Chaitarasu, Malegala, summer, winter, we can't. But we are lucky that Earth is tilted nearly 23 degrees in with respect to its axis of rotation, and hence we are lucky. We have all this beauty of ritus and seasons and so on. We are lucky. We are lucky. Next, please. Okay, please proceed. Please proceed. Okay, that's the beauty of our Earth. We are lucky. Okay. Next, please. Therefore, whenever we try to see the sun with respect to our positions, we have Uttarayana and Dakshinayana. And see, in the Uttarayana, the sunrise is from southern, from our place to up to northern side. It's only up to Ujjaini. It is not for Delhi people. It is for Udupi people or Karnataka people, and so on. And in Dakshinayana, the sunrise will be like this. We are lucky, sir. We are lucky. And Bharata Bhumi is so lucky, in which we have all these fascinating aspects. Next slide. One more point I must stress here is that, see, the Earth axis of rotation is also rotating. There are 3 types of motion in the case of Earth. One is revolution, one is rotation around the Earth, around the sun, and third one is actually the axis of rotation of the Earth, like this. This is actually now, it is towards pole star, Dhruva Nakshatra. But nearly after 13,000 years, it will be focused to Vega, Abhijit. I don't know how our ancestors pinpointed Vega, Abhijit. Abhijit is not in our 27 stars. Ashwini, Bharani, Kartika, Rohini, it is not there. But they add, even in Rigveda, Yajurveda, they added this Abhijit along with the 27 only because this axis of rotation, they guessed about this precision of Earth so early, and after 13,000 years, definitely the axis of rotation of Earth is towards Vega. I mean, this is noted. Next slide. This is noted in one book called Parashara Tantra. I'm very happy. Professor Harin Iyengar, of course, a scientist from University of Science, who had written this book called Parashara Tantra, in which he stressed about all these aspects. It's a beautiful book. I requested my students to go through and they can do some research and so on using this book. This is purely with respect to position of Earth and so on. Parashara, nearly 1400 AD. BC. He noted nearly 26 comets. 26 comets. He represented comets, types of comets, solar eclipse, lunar eclipse, the reason, and so on. I'm very happy that the Indians had done so much of work in astronomy, and that is because Indians are very brilliant because of in mathematics, because they had done so much of work. Next, please. Okay, that's enough. That's enough. Okay, let's proceed. Okay, I come to Mars. That's the beauty. Of course, we are trying to see Mars in our own way, but the beauty of Mars is that nearly on the equator, we have a canal of depth of nearly 7 kilometers, and the length of this canal is actually 2,800 kilometers, maybe from Kanyakumari to Delhi. Such a canal is there. And in all these planets, of course, there is no trace of living things, no trace at all. But in Mars, nearly 2 crores years ago, they saw some flow of rivers and so on. Therefore, they guessed that there may be some living entities on Mars in nearly 2 crores years ago. Okay, next, please. One point I must mention here that the inner planets like Mercury and Venus, they are not having moons, and we have one, and Mars is having 2, Jupiter is having 95, and now Saturn is having nearly 242 moons. That's the beauty of all these planets. The size of Jupiter is too much compared to all other planets. We can fill nearly 1,400 Earth marbles. If you guess an Earth marble, 1,400. Such a Dumma is such a big is our Jupiter. Guru is Guru, no doubt that. And Saturn is as big as like in nearly 800 times Earth, like that. Okay, next, please. Fine. Okay, that's a Jupiter. Can you show it in a better way? Slide. Okay, fine. It's a dusty planet. It's a very dusty planet. And yes, but of course, beauty. I hope you know red spot. And this dusty wind can create virals. You see, they can viral like this, and that is there on the surface of Jupiter and so on. And it's so big that we can fill 3 Earths on this size. The size is too big. Okay, next, please. Next, okay, next, please. The beauty of this one, see, when we try to see the sky, of course, Galileo first saw the 4 moons of Jupiter. Therefore, we call it as Galilean moons. How he guessed? If you try to see through telescopes every day, these spots, of course, you will see the same spots. The spots will be not in the same position. They will be at different positions. And hence they guessed about solar system that all planets are moving around the sun in their own way. It's a beauty that you can see through telescopes. Next slide. And if you have, of course, we have 8-inch telescope in which our students have taken the photo like this. This is a photo of Jupiter through telescope. Next, please. Yes, the fantastic planet is Saturn, and it's having a ring. The beauty of this ring is that from the surface of Saturn, nearly 25,000 kilometers. Then from 25,000 to 75,000 kilometers for a width of nearly 50,000 kilometers. So dusty particles are going around. Dusty particles going around like that. The beauty is that so much of moons are there. If there is a big stony structure, we call it as moon. When a moon is moving, the space is empty. When you see through telescope, you see different rings. And that's the beauty of this Saturn. It's a rings around the planet. And one more thing is that if you try to see the Saturn now, you will not see the ring. You will not see the ring. After nearly 6 years, it will be so beautiful. Hey, Noda, like that. It will be very, very beautiful. But now we can't see only because of the plane of that that planet. See, it will be like this. This is the situation that we have now. And next, it will be exhibited in its own way. That's the beauty of the rings for every year and every year. It's not saying. Next slide. Yes, like for a different year, can you go back? For a different years, the show of Saturn is different. That is the point. So this year, now we have the same situation. We can't see the ring up to September. Then we can see. For next nearly 6 years, it will be so fascinating. Next, please. Uranus, Neptune, I will not talk about this one. And so the whole system, as the solar system, is moving like this. So the system of not only the star having planets and so on, they are moving. It's too difficult to understand the motion of this particular star. Our star, nextly, our sun is moving around our galaxy in its own way with this particular speed of nearly 100 kilometers per second. Earth is moving with the speed of 30 kilometers per second, but the sun is moving with the speed of 100 kilometers per second. And okay, I'll come back to different stars now. You can see now sun. Now we have Aldebaran, Rohini. Whatever we say, Ashwini Bharani Kritika, Rohini is called Aldebaran. It is at a distance of nearly 66 light years from our sun. Now I am moving from kilometers to light years now. What is 1 light year? I need light year to talk about the distance of stars and galaxies and so on, because one light year is nothing but distance traveled by light in 1 year. Our light will travel a distance of 3 lakh kilometers per second. Therefore, one light year is, that's actually 3 lakh into 365 into 24 into 60 kilometers, such a big. But Aldebaran is at a distance of 66 light years from our sun. A beautiful Rohini Tubachanda is so beautiful. It is a yellowish star, but it is turning towards red giant. I try to say what is red giant. Next, please. See, this is of course our sun is so small compared to Rohini. We have Betelgeuse. Betelgeuse is called Ardra Nakshatra. Antares is called Jeshta. Jeshta Nakshatra is the biggest star that we have in our 27 stars. I don't know how our ancestors guessed about this. Antares is the English name, but Jeshta is our name. How they guessed about Jeshta? Jeshta means top. This is biggest. Antares, Jeshta Nakshatra, they are big, so big. Betelgeuse, I will show you. It is turning towards some super red giant to supernova now. It is burning. It is turning from like that. And of course, the same slide, Betelgeuse. And see, our sun is so small compared to them. They are nearly a few crores big compared to my sun, our sun. That's how. Okay, next, please. I proceed to different stars. It's called cluster stars. If you have Malligahu, if you have a group of flowers like that, our stars are like this. We have varieties of stars, different colors, red to blue. Okay, then okay, next. We can proceed. This is our galaxy. So much of clusters of stars. What is a galaxy? Galaxy is estimated that in a galaxy, on an average, we have 10 to the power of 11 stars. 10 to the power of 11 means it is 10,000 crores or 1,00,000,000. So much of stars are of different size. They are moving around. The average speed of our sun is actually 100 kilometers. It's a galaxy. So in a galaxy, Akash Ganga, of course, we have our Kshira Patha, but it's a different galaxy, varieties of galaxies, spiral galaxy, disordered galaxy, and so on. We have varieties of galaxy. Next, please. Next galaxy. Our sun is at a distance of, this is in terms of light years, but actually we have 100,000 light years. 100,000 light years. We are at a distance of 30,000 light years from the center of our galaxy, our sun, and so on. Okay, next, please. Okay, we have varieties of galaxies. That's a beauty. But these nearly crores of stars are grouped together in their own way. Okay, next, please. These are galaxies. Next, please. Okay, this is my liking galaxy or Andromeda galaxy. Friend, dear friends, see totally what is the universe? Vishwa, what is universe? Now it's estimated that nearly once again the same number, 10 to the power of 11 galaxies. They are called as, their team is called as universe, Vishwa. We have 10 to the power of 11 stars in a galaxy, and we have 10 to the power of galaxies in our universe, and that is our universe. In that universe, we are in our galaxy, Akash Ganga. In our Akash Ganga, we are in our sun. In our sun, we are in Earth. In Earth, with nearly 30% of land. We are in Asia. In Asia, we are in India. Bharat. In Bharat, I am in Karnataka. You're all in different places of India, maybe Mumbai or Delhi and something. See the beauty of the whole space. It is so vast and so. Okay, I proceed to evolution of stars in a very quick way. See how the stars are formed. We have a nebulae. After 100 crores of years, then there'll be, because of increase of temperature, increase of chemical reaction will start. Then after nearly one crore of years, then there may be some nuclear fusion reactions. If there is a nuclear fusion reaction, there is emission of radiation. If there is emission of radiation, we can see that nebulae in a better way, and hence there will be formation of stars. If the size of the star is smaller, like our sun, then the ultimate state of the star is after red giant, it will be white dwarf, then it will be dark dwarfs. The evolution of stars is nebulae. See, purely with respect to some, now we have finished nearly 460 crores years. Average lifetime of a star is nearly 1,000 crores of years. We finished nearly 460 crores. We have left with nearly 540 crores. At that moment, we will get red giant. Then after a few years, it will be turned into a small carbon star, and it will be next white dwarf, then it will be dark dwarf. That is the state of art of the stars like our sun, called small stars. But about the big stars, next slide. Okay, we must remember our Chandrasekhar. Yes, Chandrasekhar, he announced that all these stars will be turned into white dwarfs. There can be some other status of this one. He mentioned about Chandrasekhar limit with respect to mass of a star. If the mass of a star is more than 1.4, and then the evolution of the stars will be different. That was announced by Chandrasekhar. After nearly 50 years, he received Nobel Prize, our Chandrasekhar, and we talk about Chandrasekhar limit and so on. Okay, please. Next slide. Okay, let's finish about that slide of evolution of stars. Next slide. Okay, next slide. Next slide. Okay. See, I hope you can recognize here. Small stars after red giant, planet nebula, white dwarf, black dwarfs. If the star's mass is heavy, for heavy stars, after red giant, it will be super red giant, like our, as I just mentioned, Betelgeuse, Ardra Nakshatra is, now it's a super red giant. Now, it may burst with a supernova in a very, very few years. I don't know. So then we have supernova. Our G.T. Narayan Rao, an amateur astronomer in Karnataka, he mentioned supernova as Koti Surya Samaprabha. I mean, if there is a supernova, you can see that one in the daylight, which is such a light and so on. Then it can turn into a neutron star or a black hole. That is an ultimate state of a star. That's an ultimate state of heavy stars. Okay, next please. Okay, I will not touch upon this one because the beauty of, I like this one, is called cosmic calendar because the time is too short. And with respect to origin of this universe, now we have two theories. Of course, we are proceeding towards Big Bang theory. According to Big Bang theory, all these universe originated nearly 13.7 billion years ago. 13.7 billion years. This is a beautiful chart or calendar done by our Carl Sagan, an astronomer, and he mentioned that if you treat 1 year as 13.7 billion years, then see origin of universe is in the January 1st. Then in the month of May, we have Milky Ways. Then in the month of November, we have solar system. Then please go through in a detailed way. The turning of human was generated in the December 31st at 8:10 p.m. in our universe. We are actually so the universe is so fast, so large, so vast, and it is too difficult to understand the time and space scale of our universe and so on. Next, please. Okay, this is purely with respect to percentage. We are lucky that we have different comps. And I proceed to constellations. We have constellations. As I just mentioned, this is Cassiopeia. See, the team of stars, when you try to see the sky, we have 88 constellations. I hope you heard about Orion constellation, Scorpio, Vrishchika, we say, Scorpio. The whole team of stars is as a Scorpio. Beauty, that's all. And Saptarshi Mandal, and this is called like letter M. It's called, we have 88 constellations like that, and hence we can see the sky and we can know the sky position in a better way. And they're called, this is called once again a summer triangle. We have 3 stars in the Altair is Shravana, Denham is called Hamsakshi. On the other side, we have Vega, our Abhijit. Nearly in the month of January, February, I mean, November, December, in the western sky, we can see this one, Shravana and so on, with beautiful stars in our Milky Way. Next, please. Like that, we have 88 constellations. One constellation is very important for me. It is called Orion constellation. The red star that is there is called as Ardra, Betelgeuse. The whole star team was guessed as a warrior, Mahavyadha. See, in the top we have Mragashira. Mragashira, Ardra is red giant. Mragashira, the warrior's head. Then the two Bhuja. Then we have three stars, it is a belt. And then we have a sword of the warrior. And next we have regal, the two legs and so on. Is guessing. The 88 constellations are guessed like that. And the beauty is that in the sword, Khadga, we have Orion Nebula, in which the star formation is going on. Thus, I hope you can see the figure here, in which in the nebula, if there is a nuclear fusion reaction, then we can see the emission of radiation and so on. Now we came to know that there is a star formation in the Orion Nebula. See, please note, all the stars are at not same distance. The Betelgeuse is nearly at a distance of 600 light years, and Regal, diagonally opposite, it is called Regal, it is at a distance of 900 light years. And Orion Nebula is at a distance of 1,600 light years. We feel that they are at the same distance. They are in the Ananta Akasha in their own way. Okay, next please. Okay, but our Saptarshi Mandal, in which we can enjoy Saptarshi Mandal in our own way, they are moving like towards pole star in this manner. Next slide. Next slide. Okay, that's a Saptarshi Mandal, beauty of Saptarshi Mandal. Next, please. See, whatever I say about these galaxies and so on, it's only 4% that we see. Now, according to physics, we have nearly 21% of dark matter and 75% of dark energy. Whatever we see, all these galaxies actually 4%. We don't know anything about this. What is dark energy? What is dark matter? The new physicists like you, I mean, my students, they must come and they must understand what is the meaning of this dark matter and dark energy. This is the problem of physics today. Next, please. Yes. Okay, I like to talk about moon in a very quick way. And the moon is giving so much of beauty to our Earth. Eclipses, supermoon, move fast. See, the beauty of moon is the distance is the path of moon is not circular, it's elliptical. So, if because of elliptical path, in one round after 28 days, and at one position it's called perigee, the distance is actually near 3,56,000 kilometers nearest distance. In other case, apogee, it may be 4,05,000 kilometers. So, if we have a full moon in the perigee position, then the size of moon is so beautiful, nearly 14% larger. That moon is called a super moon. And in here, we have nearly 3 or 4 super moons in the month of October, November, December. All full moons. Please enjoy. It is super moon in which moonlight is nearly 25% more than the actual moonlight, like that. But next moon, full moon, on 12th this month, we have micro moon. I mean, the moon is at a distance of 4,05,000 kilometers. Then we have full moon. Then the size of moon is smaller. It's called micro moon. That's the beauty of moon. Next, please. Next, of course, the size will be of different size. Next, please. Okay. And about eclipses, as I just mentioned, we enjoyed annular solar eclipse in the month of December 26 on 2001-9, and we have varieties of eclipses, and it's possible to show these eclipses to our students through telescopes and so on. Next, please. Like we do all these activities in our Purna Prajna College. Our PAC is doing all these activities for publics, students of different places with different instruments. Okay, let's proceed. This is the point that I must mention. In 2019, our students prepared nearly more than 1,700 small instrument. That is called pinhole camera, worth of nearly 100 rupees. They prepared this instrument and they distributed this instrument to all high schools and ask the students to see the image of sun. If you keep this apparatus in the ground, then we will get the image of sun in the inner wall of your hall, school hall. And if you try to see, you can see the eclipse in a beautiful way. And we are lucky that in the Karnataka, nearly 1,000 schools, they enjoyed the annular solar eclipse in the month of December 26, 2019 with this instrument. Our PAC students, they prepared and they distributed and they had done it. I'm very happy. Okay, next please. Okay. Okay. Next, please. Next, please. Okay. And usually, whenever I try to talk about the astronomy, I like to talk about my Earth, my motherland. Vande Mataram, Nantai. The Mother Earth had given so much. All the slides are purely with respect to Mother Earth. Please move. And I am lucky. I am lucky because Asyuttarasyam Dishidevatatma Himalayo Nama Nagarjirajaha. Himalaya we have beauty, we have seashores, we have sunset, we have sunrise. What we have? This is a photo of in Badri. We have Nilakanta Parvata. Badri is has a height of 2,100 meters from our sea level. And Nilakanta Parvata is once again nearly 10,000 feet higher than Badrinath. And in the early morning, that whole, in the night, it will be completely dark. It's fully ice covered, In the early morning, in the month of May, if you go, in the month of May at nearly 4:30 or 4:40, the full Nilakanta Parvata is yellowish. It's like coated gold. So beautiful. In the month of October, it will be at nearly 5:45. You will see in the early morning. Such a beauty. I enjoyed beauty of this one because I enjoyed purely with respect to Raman. I remember Raman scattering, Raman effect. It's because of scattering of light. It's the beauty of nature. We have fantastic nature. That's all. Next, please. Okay, what I can say? Okay, this is the earth that we have. Such a beautiful earth. That's all. Okay. Fine. Okay. That is my earth, my motherland. We have variety. We must enjoy. We must. I request my younger generation to save all these aspects. We must not disturb. That's all. That is the aim of our pack. Next last line. And of course, not necessary. Next last line. That's all. Dear senior friends, I introduced the astronomy in my very simple way. Usually, whatever I do in front of my students. Thank you very much. Any questions that you can ask me, please. Thank you.
Thank you very much. I'm Miruna here. I have a question.
Yes, please.
Sir, I have two questions actually.
Okay.
One, we see thin moon line twice. One in the waning moon and one in the waxing moon. But one is concave shape and one is convex shape. Why so?
That is fantastic question. See, from Krishna Paksha and Shukla Paksha, moon is giving so much of problems to us. If we try to see the moon, it is because of the path of the moon round the earth, as well as light received by the sun on moon. Yes. Earth is not giving any light.
Correct.
The illuminated light is because of the position of the light received by the moon. And the axis of rotation of moon is, see, Earth is moving around the sun in a plane. Right. Moon is going around the Earth in its own plane. These two planes are not parallel. This plane is actually tilted nearly 5 degrees. Because of that, we have all eclipses. We are not having eclipses every full moon and every new moon. And the structure itself, as you mentioned, from Krishna Paksha, the structure will be different. From Shukla Paksha, structure will be different. Only because of all these planes and our observation. That's all.
Okay, thank you, sir. Second question is, during sunrise and sunset, the position on coloring of the sky, is there any particular difference? Because if we see any photograph of the sunrise or sunset, I don't spot it out whether it is a sunrise or sunset. How to differentiate?
Yes, you are right. We usually ask our students to see sunset as well as sunrise. In Udupi, we have Malpe beach, in which if you go through, sunset is so fantastic. When sun is moving down of different colors, red, but only because of scattering of light. The distance is far away. When the distance is far away from the earth, the rays from the sun must travel larger distance through atmosphere. In the evening and morning, the rays must travel larger distance through our atmosphere, and hence our atmospheric particles will scatter blue, green, yellow, everything. The left is only red. It is because of scattering. So at sunset and sunrise, the colors of sun as well as moon will be reddish because of scattering of light. It's a beauty. And even not only color, the size. At sunset and sunrise, the size will be larger because of refraction. Therefore, we say, if you see rising moon in the Hunnime, I mean full moon, it is punya. What's punya? If you see sunset, if you see moonrise, it is Mahapunya. What's the meaning of Mahapunya? So beautiful. enjoy the beauty of nature. That's all. That's all.
Okay. Sir, you just now said Earth is rotating, revolving three movements. Which are three movements? Please again.
Three types of movements. One is, let it be sun, let it be earth. Earth is moving around the sun. One type of motion. When it is moving around the sun, it is rotating. It is rotating like this. This is the second one. The last one is the axis of Earth is actually, it is also like our bugri toe, like that. It is called precession of Earth. It is called precession. For one full revolution around the sun, it is 365 days. Here, for this revolution, it is actually 1 day, 24 hours. For axis of rotation, it is 26,000 years. For this one to finish one axis, it is 26,000 years. Therefore, we have for every 72 years. I hope you heard about our Makara Sankaramana, our Yugadi is moving only because it's because of precision of Earth. And because of all these, it is possible to rethink our Ramayana Kala, Mahabharata Kala. Astronomy is reading now just to go back to history in a better way, and we evaluate the time of Mahabharata, Ramayana, Veda Kala in a better way with respect to astronomy now. And because of astronomy.
Thank you.
Yes.
Thank you very much.
This
Yes,
is
sir.
Bharat Beri. I had a question about the universe.
Please.
After the Big Bang, the universe has been expanding.
Yeah.
And because of you mentioned about dark energy and the dark matter.
Yeah.
Now, which one is going to win? Are we going to keep on expanding, or are we going to have a crunch? Big crunch is coming, or keep on expanding?
Yes, it's too difficult to see the answer because now it is expanding, sir. We came to know that the Hubble's law, from Hubble's law, we came to know that the whole universe is expanding. And we have varieties of theories. We are supporting Big Bang theory only because we have two proofs for Big Bang theory. If we get one more theory next few years, physics is like that, science is like that. If we get a better proof for other theories, as you mentioned, expand and contracting theories, there are a number of theories regarding universe. We don't know, sir. We don't know. It's purely because of matter. It's purely because of the knowledge that we have in terms of physics and astronomy, and had to know which is right and which is wrong. Therefore, for time beings, we are accepting Big Bang theory. According to Big Bang theory, the whole universe is expanding now. We know the next stage of this one. They say that there is a limit for that, and they will come back once again. And they say like that. It's purely theory, sir. It is purely quantum mechanical theory that they are predicting. And we are not getting any proof for that. And it's too difficult to talk about all these aspects. Sir, please louder.
Sir, one
Yes, sir.
question.
Yes, sir.
Sir, before the advent of GPS,
Yes.
we have heard that the navigation of ships and everything was by knowing the position of the pole star.
Yes,
Is
sir.
pole star really static? From what you said today, there can be no planet or star which can just remain static. It must have some orbit.
No. Pole star is definitely, see, to Udupi, pole star is definitely in the northern side at a height of 13.5 degree. For Bombay people, you are at a 19 degree. So to you, pole star is at 19 degree. And for Delhi people, it is 26 and so on. For North Pole people, it is at 90 degree, exactly on the top. So that is pole star is stationary for few hundred years. It will be stationary, no doubt in that. We can see pole stars, and they observe pole stars They observed Venus, they observed Saptarshi Mandal, they observed different constellations, and they will come to know about timings. My grandfather, usually, they will wake at Shukrodaya in the early morning. If the Shukrodaya, if there is, they have no time, no watch, but they observe the sky and they will calculate the time. If they say Shukrodaya, then after 2.5 years, hours, then sun will rise. They know this one, and they utilized all these observations. They are the best amateur astronomers, sir. Now we are not observing the sky, therefore we are not amateur astronomers. Our ancestors are best amateur astronomers, and they enjoyed the sky in a better way.
Thank you, sir.
I will ask you one question.
Yes, please.
Hello.
Please
Hello.
go ahead.
Please go ahead.
I want to know if a children born in USA and there is I want to see the birth chart in India. So there is any constant India and US Panchang or different Panchangas there. US is different and India is different.
No, you are right, sir. We have varieties of Panchanga here, and one Panchanga is called Dragganita. Dragganita Panchanga is better now. Sir, Panchanga, whatever we observe is 100% scientific, sir. 100% scientific. Whenever we want to see the sky, it's better to see Panchanga. Dragganita Panchanga is far better, in which they corrected the Panchanga. Even Aryabhata, even Bhaskaracharya, they mentioned that the mathematics they introduced must be corrected every 70 years. They announced it. But in some Panchangas, they had not corrected the mathematics. There must be correction. In Dragganita, they are doing the correction for their mathematics. We have fantastic mathematicians in India and Keralian mathematics. Nilakanta Somayaji, there are extraordinary observers. Even Nilakanta Somayaji observed solar system in a better way. He mentioned about heliocentric system nearly 100 years before Copernicus. They are very good mathematicians, and they announced that this mathematics, what they presented at that time, must be corrected for every 100 years. Therefore, if you correct the Panchanga, then it will be Dragganita Panchanga. Dragganita Panchanga is the best Panchanga that can have been observed. No problem at all. It may be for America, it may be for India. That Panchanga is good. You can utilize it.
Any
Is it
other question?
Yes, please.
There is
Sir?
no other question, then I take this opportunity on behalf of all others to thank Dr. Bhat extremely giving the great insight into this very complex subject. Timing hardly 45 minutes, 2 minutes. But definitely it has thrown a lot of things open to us, and those who are more interested can go deeper into the subject. Thank you very much. I also take the opportunity to thank Padmakini Madam for introducing you. We will come back to you for any further support. Thank you very much, sir.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you, AP Bhat, sir. Dr. AP Bhat, sir, for, accepting my request and, full-fledged, you have given a beautiful session today. Thank you so much. Thank you
Thank you.
so much.
The PPT is
Thank you.
prepared by
Thank
my
you, sir.
students, our
Also,
staff
the
members.
students, I thank them a lot for God bless them. God bless them. They did so much of slide showing and all. Thank you so much.
Thank you,
Thank
students.
you all.
Thanks a
Thank
lot.
you.
Thank you.
Many thanks to all of you. Thank you.
Thank
Bye.
you.